Welcome to MEI Numerical Methods, Numerical Differentiation. In this video we'll be looking at the forward difference method. Now we're interested in finding an approximate value for the derivative of f of x at this point here, which we'll call P. So we're going to consider a neighbouring point Q, and this is a magnified diagram, so the difference between the x coordinates of P and Q is a small value h, and you probably recognize this method because it's the same approach that we'd use for determining the derivative of a function from first principles. In that case we'd make h infinitesimally small, whereas in this case we'll just have a small value of h and then we may or may not make it smaller. So we're interested in the gradient of the curve at P, which is the gradient of the tangent at P, and as an approximation to that gradient we're going to take the gradient of the chord PQ. So that gradient is going to be, if we consider distance up over distance along, the distance up is f of x plus h minus f of x, and then the distance along is just h. Now we're going to apply this method to the function f of x equals sine x, and we're going to find an approximate value for the derivative when x equals 1. And a very important point to note here is that the angles have to be in radians for this purpose. You may not have covered the derivative of sine x yet, but when you do later on in the course, you'll see that it's equal to cos of x, and the proof of this relies on the angles being in radians. And just as a little illustration of how this all sort of fits together, if you've got your sine, beginning of your sine graph there, then when x equals 0, if the angles are in radians, then that will be a gradient of 1, and the beginning of the cosine graph, which looks roughly like that, then at x equals 0 you've got a cosine of 1. So as a demonstration for one angle at least, that the derivative of sine equals cos. So then if we have h equals 0.1 and plug that into our formula at the top there, then we've got a value of 0.49736 to 5 decimal places, and we can compare that with the value of cos of x at x equals 1, and it's not too far apart, although h equals 0.1 isn't particularly small, so we're going to see what happens if we make it smaller in a moment. So you might like to pause the video and try this for yourself using a spreadsheet perhaps. The spreadsheets will automatically require the angles to be in radians. And these are the values that we get for the approximate derivative as h is made progressively smaller, and as you can see they all converge on the value of the cosine at x equals 1 that we saw earlier. So that concludes the video on the forward difference method, and we'll be looking at the central difference method in the next video.